and start working on this test preview to have you good and ready so I have good things to start saying, you know, in case I have conferences with anybody's folks later in the week. So, here is our deal. This list right here, when we are breaking down radicals, one of the two numbers that you use to break down the number has to come from that boxed in list. Now, like we mentioned before, let's say you're not real sure, you know, what multiplies to get 63, much less is it some number in this list. This is when, you're like, ooh, fancy stuff flopping up here. This is when we start getting into letting the calculator do our work for us. So for instance, if I have no idea what goes into 63, I'll just try some stuff. But they have to be numbers that are in the list. So I'm like, oh, let's try 36 out, see what happens. Whoops, not plus. Ugh. Okay, that's a decimal. Decimals do nothing for me. What about 16? Oh, I'm already hearing the answer. Okay. If I get down to 9, that goes in evenly. I got 9 and 7. So once I get that part done, then the one that's in the list breaks down. Square root of 9 is 3. Okay, no more radical jail. 7 isn't in the list. That has to stay. Ooh. There you go. So that's how these work. If I throw a number in front of it, okay, for the time being, I'm going to ignore the number. Instead, now this one could be tricky, we'll see. 80. I'm going to make a little note for us up here. Okay. Whenever we're trying to find a number that goes into the 80 so I can break it down, I need it to be the biggest one. If I take a smaller one, I'll get an answer, but it won't quite be correct. It would. Now see, 4 goes in here, but 16's bigger. And again, even if you just have to take the calculator like I did before and start dividing numbers in, if that's not your strength, just go for it. So the 16 breaks down. The 5 doesn't, because it's not in my list up here. But this time there's one more part. That 2 was lurking out here. We're going to bring that down now. And our two numbers that are no longer in radical jail, we can multiply together. So 2 times 4 is 8. Square root of 5.
What if you got a number that could go like one of these?
Now, if I got 2 numbers that are both in the list, it usually means I didn't get the biggest one to begin with. So like, for instance, if I'd had 81, I'd get 9 and 9. Well, they'd both break down. But if I just looked and saw it was 81, I'd be able to do it.
Let's say the 8 was a 9. Would you break that down?
Yep.
You would break it down.
Okay. You mean this one?
Yeah,
like if this were a 9? Is this underneath a square root, though?
Okay.
The only time we're breaking them down, that's a good question. The only time we're breaking down numbers is if they're under a square root. Once they get out, they're good to go. We're not going to bug them anymore. Ooh, 128. Getting into bigger numbers all the time here.
16.
What's that?
16.
Okay. Now, I'm going to jot that down right here. He's like, uh-oh. Hardy's like, 16 and 8. Now, we're going to set this off 2 different directions. Let's give the 16 and 8 a go through here and see what happens. Ooh, now I'm hearing another option. Let's try both of these out and see what happens. So we got 16 and 8, we got 64 and 2. I completely agree that both of them multiply to 128. I completely agree that one of them's each got a perfect square. Well, because I'm kind of showing here what can happen sometimes. Because here, the square root of 16 is 4. Okay. And then I've got the 8, and I don't see that in my list. Now, if I do the other one, the square root of 64 is 8, and the 2. And you're like, well, wait a minute. You know, what's the deal? I'm getting 2 different answers. They actually both are right in some ways. This one's completely finished right now, but I can still do the other one.
Why did you get 8 with the 4?
Well, here, because if I do 16 times 8,
Wait, what? Oh, it's 6. You put 64?
I got two separate things going here.
I know, but what's the one right there? Is that 64 or is it 4?
Yeah, this is 64 and 2. Uh-huh. So then here, I notice with the 8, if I take another look, I'm like, well, wait a minute. I can divide 4 into 8. Let me look at this for a minute. So the square root of 4, because 4 times 2 is 8, square root of 4 is 2. Square root of 2. But then that 4 that I got before is sitting here, and I can multiply those together. I get the same answer either way. But here's just what I'm trying to say with this. Both work. Both are perfectly acceptable ways to go. But if I get the biggest one right away, I'm only going to have to do it once, where if I take a smaller one, it may take me a couple of steps, but I can still get there. And I just wanted you to be able to see that. So I'm glad that happened there, because it lets us see, oh, I can still get to the right answer even if I don't get the biggest one right away. So then, we step it up a little bit. All right, let's still deal with the number first. We'll deal with the exponents here in a minute. 45. We don't have a lot of choices this time.
Put 9.
Okay. So 9 works well for us. So 9 and 5. Okay. The square root of 9 is in my list, so that's 3. Leave some space for your square root of 5, because we got variables to play with this time. And remember, we're just going to do some quick division here. So here's how this works. I got x to the 4th. Whatever that exponent is, I'm always dividing it by 2, because that's what a square root is. It's a variable exponent of 2. How many times 2 go into 4? Twice. So that's my exponent on my x, however many times it goes in. If I would have had a remainder, but I don't, that would have gone on the inside. But I don't have a remainder this time, so that's all I have. With my y, again, just take the exponent. How many times, whole times, will 2 go into 7? 3. So I get y to the 3rd. But this time, so 2 times 3 is 6. I have 1 left over. So the one that's left over has to stay inside. And I'm done. So basically, the number part's just the same. I'm just taking the exponent stuff and I'm dividing by 2 is all that's going on here. Okay? And then, right, we're doing the same thing here on the next one. Again, the one that's in my list, we break down. The one that's not in my boxed-in part there, it's got to stay underneath. Again, leave a little space. Now, this first variable is kind of interesting. I got plain old x, which means it has an exponent of 1. Does 2 go into 1? No, it goes in 0 times, which means I have a remainder of 1. So this time, the only x's I have are going to be underneath the square root. But then with my y, it's how many times does 2 go into 6, because that's the exponent 3. Y to the 3rd. I got nothing left. That one's done. So when we're trying to break down radicals, that's all it is. It's going to be one of those two things. Divide by 2 on the exponent if we got the variables. Otherwise, just look for that number in the list for our number part. And if we ever are doing one of these and you've got a question on something, slow me down here for a second, because sometimes I don't think about these things, and then you guys will say it, I'm like, oh yeah. Okay, number 7, that's where we're heading right now. What are you wondering?
The 2 times, could you like add the 3 and 8?
You abs... Yep, here I notice I can't break down the 10s of the 13 anyway, but good mention there. Well, these both have square root of 10, so can I combine like terms? Absolutely. But watch the signs, they matter.
Would it be negative 5?
It would be negative 5, square root of 10. And then since there's no other square roots of 13, we just leave that one the way it is. I can't do anything else with this, okay? I can't add what's underneath the radicals. I can't add.
Wouldn't you do something with negative 5 and 12?
If these had the same radical, yes.
Oh, okay.
But since they don't, I can't do any more. But that's an absolutely good point to make, because I always want to look and see if I can break something down, because maybe they will look the same then. Oh, maybe like number 8. Now I see those aren't the same, but I might be able to break these down. So let's see if we can do something with these. Are any of the numbers up in my box there in my list up at the top going to 20?
4 and 5.
Okay, 4 does, so 4 and 5. Now here's one thing with these you'll want to pay special attention to. Okay, I'll break down my 4. That's the square root of 5. What typically happens, at least in one of the other problems, and you might want to test this theory out, is the one that doesn't break down will usually tend not to break down in the other ones. Now, it might not happen every time, but it's worth checking out. What times 5 gets me to 45? 9. Hey, what a coincidence. That's one of the numbers in the list. Square root of 9 is 3. What about times 5 to get 125? 25. What a coincidence. 25 is in the list. Square root of 25 is 5. And notice now, sort of like in number 7, we've got a deal working where?
Wouldn't it be 10 over 5?
10 square root of 5. Because I could just, since they're all like terms, I just add their coefficients together. 2 and 3 and 5 is 10. 10 square root of 5. Sweet. Okay, so sometimes it'll be able to break down, sometimes, you know, not so much.
What 9 would you just simply as?
Well, let's see. I can't do anything with 3 square root of 7. Can I break down 63?
Yeah, 9 and 7.
Okay, 9 and 7. So the square root of 9 is 3.
Then 6 over 5?
Okay, and then right, that 2 is sitting there. And actually, I'll count that like a negative 2 since I see the minus there with it. So negative 6 square root of 7. But that first part's still there, so I'll just bring it down. Yep, and since they both have a square root of 7, right, I'm going to do 3 plus negative 6 would be negative 3 square root of 7. Okay, so there's a lot of times with these, some other things will happen if you actually can break them down. Any other issues on this first page? Because again, the first page that you see tomorrow is going to look just like this. I'm just going to tweak some of the numbers around a little bit. All right. On we go. All right. Solve the following radical equations. Okay, we're going to make a quick note here. Before you start doing anything else, you want to do everything in your power to get the radical, to get the square root alone first. Because then we can square both sides and make this pretty easy. But that's only if we're being good about getting our things set up here. So, very first problem here. I want to work on getting the square root of x by itself. How do I get that positive 8 out of there? Subtract it. Okay, so I have a negative 1 square root of x equals 4. Now my radical's not quite alone yet. That negative's there still. That negative 1's still kind of lurking. What's that? One thing before that. We'll be doing that soon. So since I'm multiplying this times negative 1, what's my opposite going to be? Okay, divide by negative 1.
How'd you get negative 1?
Because there's a minus here already. So I'm already assuming that there's a 1 with that if I ever see that minus. It's sort of like dealing like I would with a variable term. Now, before, well, let's just keep going here. We'll see what's going to happen here in a minute. Okay, Taylor, what'd you say before I should do next?
Like add 2 at the time.
Okay, we're going to square both sides. Because the squared and the square root are opposites. They're called inverses. And that's why I have the parentheses here, because negative 4 quantity squared is negative times negative, which is positive. But there's an issue this time. You're like, what do you mean there's an issue? Let's plug it back in and see what happens. Okay, what's the square root of 16? Square root of 16, look at the list if you need to. 4. So is 8 minus 4 equal 12? No. We're like, well, what the heck? Okay, remember, this one is going to be no solution. But let me tell you why and where we need to be careful of that. I should have figured that out right here, back at this step. If I take the square root of a number, so back when I was to here, you can't take the square root of a number and get a negative. So if you've worked on getting that square root all by itself, and you see a negative on the other side, that automatically is going to be no solution, because square roots don't equal negative numbers, unless we have I to work with, but we don't want to play with the I right now. Okay. So if you see that tomorrow on one of the questions, you know, watch out for that, but it doesn't happen very often. All right, so 11. Want that radical alone first. What's my one step to get there? Plus the 4. Since I'm minusing 4, I'll do the opposite. Okay, we're looking good this time because there's a positive number on the other side, so our answer is going to work. Neither quite yet. I got to get rid of the radical first. Yep, we got to square first. I can't subtract right away. That radical's got to be gone first. So square root cancel. They are inverses or opposites. And again, 12 squared means 12 times 12, not 12 times 2. Again, if you need to pop that into the calculator, that's okay.
144?
Yep, 144. And I got one step left to get x by itself. Okay, so you can get some fairly big numbers for answers here. It can happen. And that's all set. A couple of more odd things that can happen to us here. So we'll bump this up a little bit. You're like, well, now how am I supposed to get the radical by itself? There's 2 of them. I can have 1 on each side. So if I see an extra 1 hanging out, I'll do an opposite. So since I'm minusing this, I'll plus that. And once I do, I'll notice that my radicals are alone on each side. So now, since that's the case, once it's alone, I don't have something else that I'm plussing or minusing by it, I can do the squared part, because the squared and the square root are opposites, they cancel out, and now I'm just left with a regular old 2-step equation to figure out what my x value is going to be.
2x versus 6x.
We could, what's that?
Add it.
Close. Since that's a positive 3x, I've got to do an opposite because they're on opposite sides of the equals.
I thought you'd minus the 27.
Well, but if I minus the 27, I'm just going to start moving it around. I need to get all my x's together first, because what you'll notice if I do that, 6 is now I've got all my x's on one side and all my plain old coefficients or my numbers on the other.
Why couldn't you like add 3x to the 6x?
Because whenever they're on opposite sides of the equals to get them together, I got to do an opposite, which is why I can't add in that case. Okay? Now, if they would have been on the same side of the equals, I absolutely could have added. That would have been a real good idea. And get my answer. So we're getting there, but they're real good questions that you're asking here too. It's going to pay off tomorrow. So one more in the solving. Yep, we need to get that out of there first, because my radical's on a side by itself. Just because it's a fraction, that's okay. And again, 3 squared is 3 times 3. And once we're rid of that, what's my last step?
Multiply by 7.
Multiply by 7, because that's a fraction and we're dividing by 7.
X equals 63.
X equals 63. Looking good, looking good. Okay, define the shifts in the following functions. Nothing to solve down here, just describing the shifts. So remember,
Left 3 down.
whatever's inside the square root, and you've got this on your note sheet, is either left or right, and then anything that's outside is going to be your up or down. Now again, if you've got your note sheet for the radicals, you can, you've got that already. And if for some reason you've misplaced yours, you can always snag them. I already have completed ones on the website anyway, so you could snag it from there if you needed to. So, and I think I already heard the answer for 14. What are my 2 shifts for 14 going to be?
Left 3 down.
Okay. Left 3, because I see the plus in there, and down 4, since I see the minus outside.
I thought you do.
That's it. On these, we're just telling me shifts. Okay, what about 15?
Up 4.
Okay, up 4. There isn't one underneath, it's just the one outside. So up 4. Tried to be foolsome, it didn't work. Ooh, what about 16?
Left 1.
You should go F6.
Good question. Left 1 for underneath. Now what about that 6? The only time I would do something would have been if this would have been like plus 6 on the end, I'd have said up 6. But if you see a number that's in front of your radical, we really don't do anything with it as far as a shift goes. So that's just they're trying to mess with you. All right, let's get into the stuff that's a little more recent here. The graphs.
And Mr. Hardy was a left 6 down there.
It was left 1, and that's it. Because on this one, if that number's in front, it doesn't do anything shift-wise. It'd have to be after it. It'd have to be a plus or minus after it.
It's just not there.
Yep, if you multiply, it's not something that we're going to be looking at shift-wise. Now then here, I'll talk through the steps again here, but again, if you're looking for what all the button presses are, every button press you need to do these is on the notes. But if you want to, grab a calculator right now and maybe just kind of replaying back through the button presses will refresh you well enough to be able to do this. So here's how this is going to work. When I go to type this in, make sure it's up there. Okay, we're good. When I want the square root button, it's second x squared. Okay. Second x squared will get me the square root. And then I just type in my x. close it up. Now I really don't need to look at the picture because all the information I need I can get from the table. In the table, again, you hit second graph. Will get me my table. Okay, so there's my table. And I go looking, oh, there it is. I go looking until I find where the errors start, because that's going to give me an idea. And I just want to plot for my points any whole number points that I see. So 0, 0 looks like a good one. 1, 3 looks like a good one. And you don't have to write, you don't have to write them down for me. If you just want to plot them, you can. I just like doing this in case any of you peek later. You can see what I'm up to. Let's see if there's any more. Oh, and 9, 9. Once we do that, I do have to complete my graph and connect the dots with an arrow on the end because that graph's going to keep going and going and going and going. So then hopefully we remember with our domain and our range, which is the last part. Okay, domain's my x's, range is my y's. And I remember with these, okay, so it's just right after that error. So right here is where I get my domain and range values. So domain goes from 0, and it's going forever to the right.
So basically your domain is your first one that you made.
The first one after error. And then my range is the first y value after error
130.
going off to forever. Still, they're both, you're going to get your x and your y from the same point. And that's all I've got on this one. Now, is there an exception? Sure there is. There's always an exception to everything. Which will actually end up being this next one. So let's see here. I've got -2. Now I need to use the white, this negative button down here. If I use the minus, I'm going to get an error message. So second square root, and then x plus 2, close it. That way the calculator knows I want the x and the plus 2 in my radical. So again, second graph. And what I'll do at the start here is I'm just looking for those whole points. So -2, 0, -1, -2, 2, -4. This one's looking a little different. 7, -6. I'll keep looking, but I have more than enough points already. Yeah, I'm going to run out of room. Okay. So this time, this one seems to be opening down, and that's okay. Get back to where's my error. There's my errors. So once I get back up here and I start seeing those errors, again, it's the point right after. So my x is -2, starts my domain, and goes off forever. But here comes the weird one again. If your graph opens down, this is the one time this is going to switch on me. Because instead of going to positive infinity and going up, my graph's going down, down to negative infinity. So if I have a range and it's going down, I start with the infinity. It starts negative. But I'm still going to use that 0. Okay? That's the only time. Domain will never flip on you like this. The range can if you have a negative number. Okay? But just kind of look at your graph too once you've gotten done with it. If it's opening down, we're going to start with negative infinity. But that's the only time it's going to happen. Yes, sir. So these last two will be normal. But again, just getting your head into the mode of how to get them typed in here. So we've got x minus 4. Close your parenthesis before the plus 2. Because I don't want the calculator thinking the plus 2 is in there too. And if I don't close my parenthesis, the calculator's going to think my little radical's going all the way over. So get my chart up here. Try to get away from all the errors. So I got a point at 4.2. Got one at 5.3.
Confused on the range.
On the last one,
No, just like,
in general?
yeah.
Okay, we'll get real specific on this one when we do this one. See if that can help out here on the range. So connect the dots here. So it's opening up, so nothing fancy. Okay.
What was the domain was 4?
Right, so the domain, my x value is going to start at 4 and go to infinity. To get the range in that same xy point, I'm just going to move to the right for the y value, and I'm going to use that. 2 to infinity, and I'm good. I can get it off the graph, but if the chart's going to tell me the same thing, I'll just use the chart. And then finally, a nice normal one to end with. X and the -6 are underneath, so I want to make sure I get that all in parentheses because it's all underneath the radical. Second table. And let's see what we got here. So we got 6, 0. We've got 7, 1. We may only get 2 points this time. Let's see. Nope, we got one more. 10, 2. Get that little arrow on the end so we see our curve. And let's see here. Where's the error messages start? Oh, the error messages start there. So we go just beyond the error messages. The x value tells us where our domain starts before it goes off to infinity. And my y value tells me where to start before I go off to infinity. This paper, okay, still counts as an assignment. So you'll want to get it in sometime, but this is just me. I'd keep this, maybe look it over real quick, your class before tomorrow, maybe look over for a second tonight. The video of this will be up later. The review itself is going to be on the website, so if you wanted a fresh one to see if you could work through it yourself and see how it's going, that's fine. But you do want to turn this in sometime to get your points. And that's where we're going from there.